everyone, this side Dr. Amit Kumar Pandey. Today I am going to discuss deadlock handling techniques. Let's see one by one. Deadlock handling strategies. So, what are the approaches for handling a deadlock? Approaches to handle deadlocks are as deadlock prevention, deadlock avoidance, deadlock detection recovery, and deadlock ignorance. What is deadlock prevention? We all know about a doctor and patient that prevention is better than cure. So this same is applied in deadlock. If we prevent all the four conditions which we discussed in previous lecture, if we can prevent all those four conditions, then we can prevent deadlock for occurring in a system. To prevent one of the necessary conditions for a deadlock from occurring, you know, resource allocation strategies avoid mutual exclusion by allowing resources to be shared, ensure that processes request and hold all required resources simultaneously, employ resource ordering, employ resource ordering to prevent circular waiting. While effective prevention strategies may impose restriction on system flexibility and resource utilization, but this is necessary for preventing a deadlock. Deadlock avoidance. What is inside deadlock avoidance? Use resource allocation graph algorithms. Use dynamic resource allocation algorithm to avoid unsafe state that could lead to a deadlock. Banker's algorithm is a classical example for deadlock avoidance. In this algorithm, process must declare their maximum resource need upfront before execution, and resources are allocated only if the system retain or remain in a safe state. But there is a constraint that requires knowledge of future resource as request is not always feasible. Next, deadlock detection and recovery. Detect and resolve the deadlock if it occurs. So, if in a system, deadlock occurs, then we have to identify where is deadlock or by which process deadlock is occur. So we resolve them. There are two or three methods for resolving means resource preemption, temporary revoke, or resources from process break deadlocks. Second is process termination. We will terminate process one by one. We will terminate one process and check whether system is in a safe state or not. If if, if it is in a safe state, then okay. Otherwise, we will again terminate another process. Then again check, terminate, then again check until system is in a safe state. Deadlock detection and recovery is less proactive compared to prevention and avoidance, but allows system to recover from deadlock states. Resource preemption. Dynamically revoke resources from process to resolve deadlocks. And what should be the criteria for preemption? Deadlock detection algorithm identifies a deadlock, determine which resource to preempt and from which process. Roll back preempt process to a safe state or allow them to reacquire all the resources which they have already previously. How to terminate a process? Select and terminate one or more process involved in a deadlock. Criteria for termination is least cost. Identify processes with minimal impact on the system and user operations. Roll back. Restore system to a consistent state after termination. Restart terminated process or spawn a new one to continue execution. Combined approach. What is combined approach? Hybrid strategies that combine prevention, avoidance, detection, and recovery techniques. For example, use prevention and avoidance strategy to minimize deadlock occurrence with detection and recovery as a fallback mechanism. provide a balanced approach to deadlock management, leveraging the strength of each technique. So at the end, we know that deadlock handling is crucial for maintaining system reliability and performance in operating system. Prevention, avoidance, detection, and recovery strategy offer different trade-off in terms of overhead, complexity, and effectiveness. Effective deadlock management requires a comprehensive understanding of system requirement and characteristics. These are some references which I have used in my lecture. Thank you all. Thank you for being with me.